And can I get a thumbs up that you hear me and see the board okay? Awesome. All right, so guys, this will probably be our last day in section 6 with the logarithmic equations that we have to solve. But now we're going to see the exponential equations. So just remember, logs and exponentials are inverses. So when we solve a log, we have to exponentiate both sides or base both sides to undo the log. When you're solving an exponential equation, you'll need a logarithm to undo those exponentials, okay? All right, here we go. So when you are solving exponential equations, for the typical ones, you're always looking to isolate the base of the exponential first, and then you can undo it using a logarithm. And then maybe for some more difficult ones, you still might want to visit that u substitution. If you have this reoccurring piece of the problem that maybe is making the problem look a little bit harder or different, maybe we can substitute a u in its place. All right, so let's look at the first one. This is as basic as they're ever going to get. So if you have to find out 3 to what power is 7? Well, guys, I know 3 to the first is 3. I know 3 squared is 9. So I know that must be 1 point something. It must be some type of decimal in between 1 and 2. But I don't know which one. And we can't sit here guessing and checking the entire time. So in a perfect world, what would undo a base 3 exponential? A base 3 log. I get that. However, just going back to the way math originally started with logs, calculators were never programmed, like I said, to do a base 3 log. So a lot of math books allow you to leave your answers only in base 10 or base E logarithms. So to just take the log base 3 of both sides, yeah, it works, but your book is then going to make you use the change of base formula to change it to a base 10 or a base E answer. So I'm not going to do that. If I'm going to undo an exponential, I'm just going to take either the log base 10 of both sides, or I'm going to take the natural log of both sides. It's your choice, but those are the two best bases to work with, base 10 or base E. When you get to calculus, base E will be a little bit more user-friendly when you're doing the derivatives, so I'm going to try to train you guys to natural log both sides. All right, so what I'm going to do is I'm going to natural log both sides of the equation. It doesn't cancel any of our bases out. You're literally left now with the natural log of 3 to the x, and it equals the natural log of 7. So it's kind of like, well, Marty, what did that do? Well, by creating a log, the whole point of an exponential is the unknown is the exponent. But now that I have an exponent inside of a log, I can use my log property that says that exponent can come down in front as a property now, as a factor. So now it's x times the natural log of 3 equals the natural log of 7. And now all you have to do to solve for x, this unknown value, is divide by the natural log of 3. So x equals the natural log of 7 divided by the natural log of 3. So that's your exact answer. The missing exponent you need is the natural log of 7 divided by the natural log of 3. I think your homework asks for the exact answer and then the rounded answer. So if you asked your calculator what's the natural log of 7, but close the parenthesis, divided by the natural log of 3, you get 1.77-ish. So it's approximately 1.77. But I'm pretty sure they're going to ask for the exact and then the rounded. Okay? Easy enough. So again, I wish we could just take the log base 3 of both sides, and then the answer would be log base 3 of 7. But they don't let you leave it in a base 3 log. They make you then use the change of base to change it to base E or base 10. All right, let's look at example 2. Same thing. Our job is to solve for x, which is an unknown exponent. X is only on the 2. So the 2 is your base. So you want to get the base by itself, so you have to divide the 5 away. You don't want to take the log too early. So now you have 2 to the x equals 3/5. Now, to undo an exponential, I'll log both sides. So I'm going to natural log both sides. But again, you could log both sides as well. They let you do base 10. So now you get the natural log of 2 to the x equals the natural log of 3/5. Now that we have an exponent inside of a log, we can drop it down in front as a factor. So x times the natural log of 2 equals the natural log of 3/5. And now all you have to do is divide by the natural log of 2. And now your exact answer is the natural log of 3/5 divided by the natural log of 2, which is approximately, what did I say? Just bear with me, I hate this calculator. Negative 0.74. Depending on how many decimals they ask you to keep. Now, guys, just remember, when you're working with exponentials, a couple things you want to check for. When we were working with logarithms, we had to check for extraneous solutions. Well, the nice thing about exponentials is that the missing value is an exponent. And the exponent, if you remember, was allowed to be anything. A negative number, a positive number, a decimal, a fraction. The domain of an exponential was all real numbers. But its range, only positive numbers came out of an exponential. So you may deal with extraneous solutions if you say that the answer to an exponential is a negative number or 0. That should not happen. But as far as what x should be, as long as x is the exponent, there should be no extraneous solution. X should be allowed to be anything, big, small, positive, or negative. All right, let's go to the next example. All right. This one causes a little bit of drama because you have a base 2 exponential on this side, and then you have a base 5 exponential on that side. So the bases aren't the same. At least, though, the bases are isolated. It's just 2 to this power equals 2 to that power. So to begin the solving process, I will take the natural log of both sides. I do have my bases isolated. Unfortunately, though, they are different bases. So you end up with the natural log of 2 to the x minus 1 equals the natural log of 5 to the 2x plus 3. And again, the good thing about doing this now is now I have an exponent in a log that can now drop down in front as a factor. So now you have x minus 1 times the natural log of 2. Same thing, I can drop this down, and now it becomes 2x plus 3 times the natural log of 5. So guys, our job is to solve this for x. I got x over here, I got x over there. Now we're going to have to get everything with an x to one side and anything that doesn't have an x to the other side. So let's get rid of these parentheses by distributing. So it'll be the natural log of 2 times x, which is x times the natural log of 2. And then the natural log of 2 times negative 1 is negative the natural log of 2. Equals, now let's distribute the natural log of 5 times 2x is 2x times the natural log of 5. And then the natural log of 5 times 3 is plus 3 times the natural log of 5. So right now what we're going to do is we're going to get anything with an x to the left and anything that doesn't have an x to the right. So I'm going to leave this, but minus this over. And then I'm going to leave that, but add that over. Everybody okay? We're all right at this point? All right, so now, by moving everything with an x to the left, what does this term and this term have in common? An x. We can factor it out. Factor out the x. And now the only thing you have to do to get x by itself is divide by that. And unfortunately, with all this adding and subtracting, we can't cancel any natural logs of 2s or natural logs of 5. So guys, right now you have this. X equals 3 times the natural log of 5 plus the natural log of 2 divided by the natural log of 2 minus 2 times the natural log of 5. Now, what happens is We always in math want to simplify answers, right? So when you get here, this isn't wrong. This is an exact answer. But guys, it can be cleaned up. It can be simplified. I can throw this back up to be an exponent. I can throw this back up to be an exponent. Then I can put these two logs back together using multiplication since they're separated by addition. So stay with me. So x equals the top. If I put this back up, it'll be 5 to the third, which is 125, right? Then I can put these logs back together as the natural log of, I can use multiplication. 125 times 2 is 250. So the top actually simplifies to the natural log of 250. Again, that's by putting this exponent up and then putting these back together using multiplication. And then on bottom, I can put this back up so it becomes 5 squared, which is 25. And then I can put these two logs back together using division since they're separated by subtraction. So then it becomes the natural log of 2 divided by 25. And now that is your simplified answer. So just be careful. If they ask you to simplify your answer, you may have to condense all this back. All right? I had a hand raised. Go ahead.
Where did you get the 125?
Because if I put this factor of 3 back up, it's 5 to the third. 5 to the third is 125. Is that okay?
The natural log of 2.
This natural log of 2?
No, the other one. It just moved in front. Okay.
Yeah. Is that okay? All right.
Yeah.
All right. All right, now we get to the fun ones. All right, so guys, look at example 4. I'm actually in the way of it right now, so I just want to give anybody a chance to finish writing that. So again, a lot of times when we get to certain problems, they're really testing your ability to see the way to rewrite things in an equivalent way. Am I good to erase that? Are you guys okay? Are we good? I don't want to erase anybody. I don't want anybody to feel like they missed something. Okay. All right, look at this one. So now our job is to solve this one for x. He's an exponent here, he's an exponent there, base 9, base 3, it's chaos. So when you have this case where I was able to isolate one exponential equal to another exponential, it wasn't that bad. However, with this just 6 that would be on the side as one of them, it's not going to be as simple. So in this case, you really want to get things in the same base. So I know 9 can definitely be rewritten as a base 3. I can rewrite this as 3 squared to a power of x, right? 3 squared is 9. And now I've created the same base throughout this problem. And then it's minus 3 to the x, minus 6 equals 0. All right, well, now I'm going to do this. This 3 to the x, I can make him reappear. I know that power to power I would multiply. And the order in which I multiply doesn't matter. So I could really rewrite this as 3 to the x squared, right? Because 2 times x, x times 2, it's all the same thing. But now I've made that 3 to the x reappear. Now, some of you are very good at factoring this when it looks like this, but a lot of people see it better when you use a u substitution. So now, let's let u equal this reoccurring 3 to the x. And then watch how much simpler on the eyes this problem becomes. So that's going to be u squared minus, u minus 6 equals 0. So guys, at the end of the day, it's like you have a quadratic equation to solve. Let's hope it factors. If it doesn't factor, we'll have to use the quadratic formula. All right, I know u and u. I'm looking for numbers that multiply to negative 6 and add up to that negative 1. I'm going negative 3 and positive 2. So then you end up with the statement, if you solve this one, u would equal 3 and u would equal negative 2. Now that you've solved it for u, go ahead, throw the 3x back in there. So really it's 3 to the x who equals 3. And really it's 3 to the x who equals negative 2. But there's a problem with that one. All right, so guys, you can look at this one right now. 3 to the x equals 3. Who does x need to be to make this statement true? 3 to what power is 3? 1. It's got to be 1. We know the answer. If you went through, take the natural log of both sides, guys, you would get this. The natural log of 3 to the x equals, the natural log of 3. X would come down, and then you'd end up dividing, and you'd have the natural log of 3 divided by the natural log of 3. That's 1. So even if you didn't notice that, even in the solving, you get an answer of 1. All right, but now, guys, there's a problem with this one. 3 to the x equals negative 2. Is anything, any positive base raised to any exponent ever equal a negative number? Do negative numbers come out of an exponential? No. And if I tried to solve this one by taking the natural log of both sides, then I'd be taking the natural log of a negative number. Are we allowed to do that? No. So this is extraneous, and we only get one answer. An exponential should never equal a negative number because the base of an exponential is always positive. That's by definition. So that's what I mean. You could get an extraneous solution when you're telling me that an exponential equals a negative output. That should not happen. All right, let's go to the other example. Let's go. Keep it moving. Are we okay? I know I'm flying. Is everybody okay? Okay. The more examples I get to do with you guys, the better I feel, so. All right, I'm gonna give you guys just like a minute head start. Is there anything that, coming off of the last problem, that you might want to rewrite? I definitely see a 16, and I see a base 4. So is there anything you might consider rewriting? This one has another little hiccup that we have to tackle. But is there anything you definitely want to rewrite? Absolutely, right? I would take that 16, I would rewrite it as 4 squared. Excellent. So now watch this. If we rewrite this as 4 squared to the x, right? This one doesn't have a reoccurring 4 to the x. This one has a 4 to the x plus 1. So it's not like I'd be able to create that 4 to the x right now. Or could I? Guys, think about it. These exponents got added. What do we do in math that makes us add exponents? When we multiply the same base. So technically, I could rewrite this as 4 to the x times 4 to the first. I could split these up into separate exponents with their own base. Because guys, at the end of the day, what would we do to this? 4 to the x times 4 to the first, same base, multiplying, what do we do with their exponents? We'd add them. It'd be 4 to the x plus 1. So I can split this into 2 individual base 4 exponentials. And then it's plus 3 equals 0. Well, now watch this. Let's rewrite that as 4 to the x squared minus 4 to the first is 4, guys. So I'm going to rewrite that as 4 times, I'm going to put 4 to the x after it because the order in which we multiply doesn't matter. And then plus 3. So now I can see I do have a reoccurring 4 to the x. Let's let u equal 4 to the x. So then you'd have u squared minus 4 times u, and then plus 3 equals 0. And let's hope it factors. We've created another quadratic equation where I could say u minus 3 and u minus 1 equals 0. And it does factor, right? So now I get u equals 3 and u equals 1. All right, well, now that you've solved it for u, now we got to put what u is equal to back in. So it's not u that equals 3, it's 4 to the x that equals 3. It's not u that equals 1, it's 4 to the x that equals 1. All right, well, this one, 4 to what power is 3? Beats me, right? Natural log both sides. So then you get the natural log of 4 to the x equals the natural log of 3. Now that I have an exponent inside of a log, we drop it down. And we get the exact answer, which says x is the natural log of 3 divided by the natural log of 4.
On this part,
Go ahead, Michael.
if you wrote 4 the x equals 0 instead of for the x.
I did.
Okay.
Perfect. Thank you, Michael. No, that's perfect. Thank you. I appreciate that.
Sure that was.
No, you're right. Excellent. All right. And then the natural, I hate this calculator. I don't know why I have it out. You have to go through 8,000 buttons to get to the logs. The natural log of 4, close it. Oh, no, it's 3. Divided by, and again, if they have a parenthesis as to what you're taking the log of, make sure you close it. Otherwise, you'll include what you're dividing by as part of the first log. And you get about 0.79 is the missing exponent there. All right, and then last, well, guys, 4 to what power is 1? What does the exponent have to be? It's got to be 0. And even if you didn't know that, you would have taken the natural log of both sides, and you would have gotten x times the natural log of 4 equals the natural log of 1, and then x equals the natural log of 1 divided by the natural log of 4. Well, guys, they expect you to know that anytime you're taking the log of 1, this is saying e to what power is 1. What is always the power that's going to be needed to equal that 1? Because the base is never 1. It's 0. So this is literally 0 divided by the natural log of 4. What's 0 divided by any number in the entire world? You still get 0. Okay? All right, how do we feel? Basic enough? We okay? Everybody's good?
Can you keep that right?
Yep.
Area.
And I'm going to go for it. I'm going to leave this. I'm going to move it up. We're going to try the last problem. The last problem is definitely different to get you started, but they give you a hint. And the hint gives everything away because it's exactly how we're going to do the problem. All right, so look at this one. They want us to solve this for x, right? But they gave you a hint, and the hint says multiply each side by e to the x. So if I'm going to multiply this side by e to the x, which again is e to the x over 1, so it's really just the top that you're multiplying by e to the x, and then times by e to the x. So guys, e to the x times e to the x is going to be e to the, add your exponents, x plus x, 2x. And then e to the x times e to the negative x is going to be positive. E to the x plus negative x is 0. You add your exponents. And then it's over 2 still. Equals 3 times e to the x is 3 e to the x. All right, well, let's clean this up a little bit. E to the 2x plus, that is 1, equals, over 2, equals 3 to the ex. Now it's a proportion. Let's cross multiply. So I'm going to get e to the 2x and then plus 1 equals 6e to the x. Let's move everything to one side, and let's see if I have this kind of reoccurring e to the x. Let's see if maybe we could use a u substitution. Michael, are you still okay?
Yeah, you can go.
Okay. So now I have e to the 2x. I'm going to minus that over. And then I still have my plus 1. So I'm going to manipulate this as e to the x squared minus 6e to the x plus 1. And now I can let u equal that e to the x. And then it's going to become u squared minus 6u plus 1 equals 0. Now, unfortunately, guys, we have finally gotten to one. It doesn't factor. So if it doesn't factor, we're going to have to use the quadratic formula to get our answers. So it's going to say u will equal, the opposite of b is 6 plus or minus the square root of negative 6 squared minus 4 times a times c, all divided by 2 times 1. So u will equal 6 plus or minus the square root of, that's going to be 36 minus 4, it's 32, divided by 2. All right, let's clean that up. That's what? The square root of 16 times the square root of 2, that's 4 root 2. So u will equal 6 plus or minus 4 root 2 over 2. Now, everything on top divides by 2, so keep simplifying. U will equal 6 divided by 2 is 3, plus or minus 4 divided by 2 is 2 root 2. So guys, our two answers, one of them is when u is equal to 3 plus 2 root 2, and the other answer is when u is equal to 3 minus 2 root 2. I'm just splitting those into two separate answers. Now that we've solved it for u, put the e to the x back in. And now, when I natural log both sides, the natural log and base e cancel each other. It's actually a good base. So if I natural log both sides, the natural log base e and a base e exponential, they cancel. And x is equal to the natural log of 3 plus 2 root 2. Now, as long as 3 plus 2 root 2 is not a negative number or 0, you're okay. And guys, it's not. The square root of 2 is like 1.4 times it by 2 and add 3. It's definitely going to be a positive number bigger than 0. All right, take the natural log of both sides. They cancel, and x is equal to the natural log of 3 minus 2 root 2. And I don't believe that's extraneous either. I thought I wrote it down. It's about 0.17. So that's perfectly acceptable as well. It's not 0 and it's not a negative number. And those are your two solutions. Do you guys feel okay? I know that was a lot. Are you guys all right? Yes? All right. So there is a homework on exponentials tonight that is due tomorrow. Guys at home, I know that was a lot. Are you guys okay? Yes? Okay. Let me double check the attendance and then you guys are going to be good to go. Guys, I'll see you.